algebra students. Mr. Lawrence here with your next flipped lesson, and we're going to be working with variables with exponents. And the first part of this is just total review. You already know how to do this. I just want to refresh your memory and point out to you that some of the things are going to be a little bit different when we get into the multiplication. But if we have to add or subtract, all we're doing is, what's that? What'd you say, Alex? Yeah, that's right. We're just combining like terms. And so if I look at this first problem here, I've got 5x to the fourth. I've got a positive 3x to the fourth, and I have a minus 4x to the fourth. And they're all like terms, so all I have to do is put them together. I'll bet you Evan can tell me the answer. Go ahead, Evan. Figure it out. All right, let's see here. Yeah, Evan, you're absolutely right. 4x to the fourth. Very good. All I did was combine my like terms. Now, of course, in a situation like the one below, um, we have some distribution to do here, right? Because of the negative. Let me highlight him. There we go. So we have some distributing to do. So I'm going to rewrite the first quantity, 6x to the fifth, minus 4x cubed, plus 2x squared, plus 3x. And then I'm going to distribute my negative. And I'm going to write him in green so you can tell the changes that may have occurred. Minus a 5x to the fifth. Does that look like a 5? Let me make it look more like a 5. There we go. And a negative times a negative 2 would be a positive 2x to the fourth. And then a negative 3x squared. And a plus 3x. All right, so now I'm ready to go and highlight my like terms. So I've got 6x to the fifth here. And I've got minus 5x to the fifth there. Those are like terms. I don't see any like term with this guy. I see him, but I don't see another x cubed term. Okay, I've got the 2x squared, the positive 2x squared, and the minus 3x squared. Ooh, that really looks good. I didn't know how green on green was going to look. And let's switch to another color here. And then I have a positive 3x and a positive 3x. And one more color looks like it's necessary. I guess I haven't used this one. And so now I'm just going to combine my like terms. And again, this should all be review. You should know what's going on. Okay, so my yellow ones will yield an answer of x to the fifth, right? Because 6 minus 5. My light blue one is all by himself, so he doesn't combine with anybody. Oh, wait a second. Hold on. That is true, but I'm going to do my pink one first because it's next to the fourth. 2x to the fourth. Now I can do my light blue one. Neither of those combined with anybody. My green ones end up being a minus x squared. And my kind of orangish ones end up being plus 6x. And I'm done. There's no equal sign in there, so I can't solve for x. And none of those are like terms because they're all different powers of x. Now, before we get to multiplying, I want to ask you what this means. Not what does it equal, what does it mean? Hopefully you know this means 3 times 3 times 3 times 3, that there are 4 3's being multiplied together, right? 3 times 3 is 9, and 3 times 3 is 9, and 9 times 9 is 81. So therefore, 3 to the 4th power equals 81, right? Okay, so keep that in mind. The exponent tells us how many of there are of the base. This is our base, and this, of course, is our exponent, right? Okay, so let's go and see if we can figure this out. All right, I'm multiplying x to the fourth times x to the second. Well, doesn't x to the fourth mean x times x times x times x? And doesn't x to the second mean x times x? Now, let's go over here for a second. If I had to do 7 times 7 times 7 times 7 times 7 times 7, that is a mouthful to say. Isn't there an easier way I could say this? I'll bet Holly knows. I'll bet she knows to say that the base would be 7 and the exponent would be 6. She could say 7 to the 6th power. Isn't this what that really means? Right? We talked about it up there. Now we're just going the other direction. So if I'm multiplying all these x's together, there's 6 of them, aren't there? What must x to the x times x times x times x times x equal? Must equal x to the 6th power, because there's 1, 2, 3, 4, 5, 6. Yeah. Okay, let's do number 2, and I'm not going to write it all out. This one here, doesn't it mean there are 10 x's? And this means there are 5 x's. And so I'm going to have x. How many x's are being multiplied together? Well, there's 10 here, 5 there. There must be 15. Yeah. Let's check this one out. X times x. Well, another way to say 3 times 3 would be 3 to the 2nd power. So x times x, what's that, Jake? Yeah, it's x squared. Very good. Very good. Okay. Now, on number 4, I have a different situation, but not really. It's actually pretty simple. All you're going to do is you're going to take what you know how to do. You're going to multiply the 5 times the 2. And that's easy enough. And then you're going to multiply the x cubed times the x to the 4th. And you're just going to multiply them together. That's it. So 5 times 2, of course, is 10. There's 3 x's here. There's 4 there. Altogether, there's 7. So it's 10x to the 7th power. And there you go. All right, let's drop down to numbers 5 and 6. Oh, by the way, did you notice anything? Did you notice that we had a 4 and a 2 and we got a 6? 4 plus 2 is 6. What's 10 plus 5? Oh, it's 15. Are there exponents here? I'll bet you there are. You might disagree with me, but I'll bet you know that there's a 1 here and a 1 here. Well, what's 1 plus 1? It's 2, isn't it? This is not a coincidence. 3 plus 4, and we end up with 7. There's a rule, and you'll want to write this down. You want to have this in your notes. Okay? And it says when the bases are the same. Oh, let me start this over. If I am multiplying like bases, add the exponents. Yeah, if I have like bases, meaning they're the same variable, or it doesn't have to go with variables. I mean, it doesn't have to. It certainly applies. But if I had, say, 5 squared times 5 to the 3rd, I'm telling you that's the same as 5 to the 5th. Let's see, this would be 25. This would be 125. And probably should know a cool trick for 25 times 125. I don't, so I'll do it the old school way. And let me see here. I'm going to get 5, carry the 2, 12, carry the 1, 625. And then I'm going to put a 0 placeholder. I'm going to 0, carry the 1, 5, 2. And it looks like it's going to be 3, 1, 2, 5. Yeah, 3,125. So I'm telling you that this is 3,125. Well, let me go to Google. Let me find Google. Okay, remember we got 3,125. And what if I do 5, and this little caret means to the power of, 5th power. And let's see what the calculator tells me, 3,125. I got the same answer. So you see, it doesn't apply to just variables. If the bases are the same, like for example, let's say I had, let me find something here. Where is it at? Here we go. If I had hexagon to say the, I don't know, 12th power, and I was multiplying it by a hexagon to the, I don't know, 13th power, that would be the same as a hexagon to the 25th power. 12 plus 13 is 25. It only works if the bases are the same. I cannot do it if I have like x to the third times y to the fourth. That would simply be x cubed y to the fourth. I don't add the exponents because the bases don't match. Okay, let's go back to our problems here. And we've got problems 5 and 6. Well, I'm going to multiply the negative 7 times the positive 8 and get a negative 56. And then I'm going to multiply those two together. They are like bases. 8 and 5 is 13. And bam, I'm done. Look at how simple that is. All right, number 6, 1/3 times 24. Well, you could think about it this way. You guys have been doing so well with your fractions. You see a fraction that'll simplify? I do. That would turn into what? 8 over 1. So 1/3 times 24 must be 8. Now my bases are the same here, and so I can add x to the 17th. And that's it. It's that simple, ladies and gentlemen. All right, please take notes on the video. Watch it again if you need to. Write down questions. You know, if you've got a question, you don't know what's up, you should be writing it down and then asking me in class. You know, if you're there early, you can ask me early. You can ask me during class. All right, you can ask me during the formative. I would love to answer your question for you. Okay, Mr. Lawrence signing off. Good night, everybody.